Very good morning, students. So, in the last lecture, we have revised some very important definition of a chapter, that is what do you understand by units, what do you understand by measurements. Then in the lecture we have done what are the different types of system of units. So there were three types of system of units. First, that was SI system, MK system. Then we have CGS system, and then we have FPS system. Now, if you remember, we have realized that the units are of two types. First, the fundamental unit, and second, the derived unit. The fundamental unit was the independent unit. It does not depend on the other units. That means if you want to derive, if you want to find out the fundamental unit with the help of other units, we can't do that because it is independent. Second, there was derived unit. In derived unit, we derive the unit, that means we make the units with the help of fundamental units. Now let's quickly, if we have units, and you know that units are basically used to measure quantities. That means these fundamental units must be made to measure some fundamental quantities. So let's talk about what are and how many fundamental quantities are there, and what is the unit of the particular fundamental quantity. So if we talk about fundamental quantity and units, I am making a table here. Let's suppose this is the serial number. Here I am writing the quantity. Here the unit. Here I am writing the symbol we use to write the unit. So first fundamental quantity is length, right? And you know that length is measured in meter. So that's meter. Symbol of meter is simply smaller. The second fundamental quantity is mass. Unit is kilogram. I think we are studying this unit since class 6th or 7th, right? And symbol is kg. Third, we can take time. Time. You know, time is always measured in sometime in hours and minutes, but the fundamental unit of time is second. So it is second. In short, small s. Then the fourth, that is electric current. Right? Electric current is measured in terms of ampere. Symbol is A. Fifth, thermodynamic temperature. Now this is not any other temperature. This is a simple temperature that we use to measure in day-to-day life, like the temperature of the city, temperature of the body, temperature of the water. It is same temperature. So don't get confused with the term here thermodynamics, right? So the unit of the temperature is Kelvin. You must have heard there are some other units also like degree Celsius and Fahrenheit and degree Fahrenheit, but out of these units we only use Kelvin as a fundamental unit of the temperature. It is symbolized by K. Sixth is amount of substance. It is given by mole. In short, MOL, and 1 mole, seventh fundamental quantity, and its unit is luminous intensity of light. Now what is this? Basically, luminous intensity of light shows how bright is the light. For example, if you take an example of, we have two bulbs. First bulb is of, let's say, 60 watt and the another bulb is of 100 watt. You know, the bulb of 100 watt will be more brighter as compared to the bulb of 60 watt. Then that means the luminous intensity of the 100 watt bulb is more as compared to the 60 watt bulb. Now if you compare the luminous intensity of 100 watt bulb with respect to the 1000 watt bulb, then obviously the luminous intensity of 1000 watt bulb is more as compared to the 100 watt bulb. So basically luminous intensity shows how the light is bright or dim, right? It is measured in candlelight. In short, C. So these are 7 fundamental quantities and their unit along with their symbols. Other than these quantities, there are no quantity which is fundamental. That means you can say there are thousands of units in the physics, right? All the units are basically derived from these 7 units, right? For example, unit of volume, that is meter cube, derived from the meter. Unit of density, that density is mass upon volume, yani kg per meter cube, again kg and meter. Unit of speed, that is meter per second, meter and second. Unit of charge, SI unit of charge is coulomb, but 1 coulomb is equals to 1 ampere into 1 second. Again, ampere and second. So you are saying that all other quantities, all units are basically derived from these 7 units, right? So that's the significance of our fundamental units and the quantities. Other than these quantities, we have 2 more quantities and the units are known as complementary quantities and their units. So let's quickly talk about them. Complementary quantities and their unit. So first is plane angle. Now what does it mean? First let me write the unit and symbol, then I will talk about what is plane angle. So the unit is radian, and in short we write it as RD. Now what is plane angle? Plane angle is defined as the angle subtended by the arc at the center of the circle. For example, let's suppose this is the arc. And if you complete the arc, it will make a circle, obviously, like this. And now if there is a circle, there must be some radius and center as well. So let's say this is the center. So this is nothing but the radius of the circle, and this is the length of the arc, let's say S. So again, how do we define it? The angle subtended by the arc. So this, can you see, this is the angle. Who is subtending this angle? This arc. If you take these two ends of the arc and join at the center of the circle, it will make a certain angle. And that angle is sometimes denoted by theta, sometimes alpha, sometimes omega. There are so many symbols. But simply logically, you understand the logic. This angle is called plane angle. What is the formula? Formula is angle equals to arc upon radius. Right? Arc length and radius. Although you must have noticed that in your mathematics book, this angle is given in terms of degree. Like the line is making angle 60 degree with the other line, or 90 or 30, whatever. Now what we do if the angle is given in terms of degree, right? We can't use the angle which is given in degree directly in the question in which the quantities are given in MKS or in CGS. First, we have to convert this angle into the terms of radian. Now, how do we convert it? Always remember, 360 degree makes 2 pi radian. You know the value of pi, it is 3.14. So obviously 1 degree will be pi upon 180 radian. So if we want to convert degree into radian, just multiply by pi upon 180. For example, in an equation, it is given that the angle is 30 degree. So as I said, I can't use directly this angle into the question. First, I have to convert into the radian. Yeah, we can use this angle at 30 odd in a degree if the quantity is given in the trigonometric quantities like sine, cos, tan. Right? Otherwise, we have to change it. So theta is 30 degree. How do we convert? Just multiply by pi upon 180. So it will give you 30 into pi upon 180. So it will give you how much? Pi by 6 radian. So 30 degree can be written as pi by 6 radian. Alright? So that's your plane angle. Unit was radian and the symbol was RD. The second is called solid angle. Now what is solid angle? Let's quickly understand it. So solid angle is the another we must say the complementary quantity, solid angle, right? The unit is say radian and it is denoted by st.r. Now to understand the concept of the solid angle, I have this metallic ball. I take out from my stairs. Okay, so now you can see this is not a 2D structure, unlike the Circle. Circle is a 2D plane. It have only x and y. But if you talk about this is a 3D structure. Now if you want to find out the angle at the center, now who will make a angle at the center? Suppose you consider a small area, this, right? I'll keep it close to the camera. Okay, can you see this? I have make a circle here. Now I want to check that this circle, what is the angle made by this circle at the center? Now I try to make the diagram here. Suppose this is a sphere, this, and I have considered a small area element on the surface. Now this surface area will make a certain angle at the center. Just imagine I cut this portion in the shape of a cone. From the surface to the center I am going like this. So just imagine at the center there will be a 2D angle. This one. And this angle is called the solid angle. Right? So how do we define this? We will define the angle subtended by the area at the center of the sphere. And that will be the solid angle. What is the formula? The formula is solid angle is equals to surface area upon radius squared. For example, I want to find out the solid angle subtended by the sphere, this complete sphere at the center. Then we must know what is the surface area of sphere, that is 4 pi r square. So 4 pi r square upon r square, from r square is cancelled. So it is given as 4 pi steradian. Right? Now symbol, it is denoted by the angle omega. That is omega, that's not W, that is omega. So that's your plane angle and solid angle. So we have done our fundamental quantities and the units along with the symbol, and two complementary units and their symbol. Let's talk about prefixes. Now what are the prefixes and what is the significance of prefix? Suppose you want to measure the length between let's say between two walls in the room. Then inside the room you can measure distance in terms of meters. You will say yes, okay, that the distance between these two walls is, let's say, 5 meters. That's fine. But now if you want to find out the length or the distance between your home to school, you will say, sir, it is 4,000 meters. Now when you say 4,000 meters, it's quite, you'll be uneasy. 4,000 is quite bigger unit. Why we can't say that it is, instead of 4,000 meters, we can say 4 kilometers, right? Alright. Now if we say the distance between the earth and sun, it is too much, right? Then if we increase the amount of distance, then what we do to make the calculation easier, we write. So basically, to use a larger quantity, we use prefixes. There are two types of prefixes. Prefixes, first we have large prefix and smaller prefix. What are large prefix? First is deca. Deca, the short form or the symbol for deca is DA. and power is 10 to the power 1. Now what does it mean? Suppose you are the length given between 2 points is 2 decameter. It means that 2 decameter, and you know that 1 decameter is equal to 10 to the power 1. So it must be 2 into 10 to the power 1, that is 20 meter. So instead of writing 20 meter, we can say 2 decameter. Then second one is hecto. For hecto we use H. It is 10 to the power 2. Then kilo, you all know kilo. K, 10 to the power 3. Suppose we say kilogram. So when we say 1 kilogram, it means 1 into 10 to the power 3 grams. Or kilometer, 1 kilometer is 10 to the power 3 meters. Then we have mega, that is M, 10 to the power 6. Then we have giga, 10 to the power 9. Tera, 10 to the power 12. Peta, 10 to the power 15. Hexa, 10 to the power 18. Zeta, 10 to the power 21. And the last one is iota, 10 to the power 24. So if these symbols are put before the units, that means first we have to convert them into the fundamental unit. For example, if the length between 2 points is given 1 megameter, so I can't just use directly formula using 1 megameter. First we have to convert this megameter into meter by multiplying the factor, that is 10 to the power 6. So 1 megameter can be written as 10 to the power 6 meters. Similarly, we have smaller prefixes as well. Let's talk about them as well. You can take the screenshot of this. Smaller prefixes. First, we have deci, small d, 10 to the power minus 1. Centi, like centimeter, 10 to the power minus 2. Milli, m, 10 to the power minus 3. Like suppose in the question it is given that the length between 2 points is millimeter. I can't use directly millimeter. First we have to convert it into the meter by multiplying by a factor 10 to the power minus 3. Then micrometer. The symbol is mu, 10 to the power minus 6. Nanometer, nano, that is n, minus 9. Pico, minus 12. Femto, f, 10 to the power minus 15. Atto, minus 18. Zepto, minus 21. And the last one is Yoto, minus 24. So these are the prefixes. They are very important. So you must remember all of the prefixes to convert them into the fundamental units. So that's all about today. In the next lecture, we'll talk about the units of length. Thank you so much.